Question 19 is asking us to graph the linear inequality this time. And so what I would end up doing on this problem is typically I would end up using xy intercepts, but I noticed that my x-intercept is going to be a fraction. So since y has a coefficient of 1, all I would have to do is subtract this 3x from both sides. So I'm going to go ahead and do that. And what happens is I've got an equation in slope-intercept form, and this will be easier to graph anyhow. Negative 3x plus 2. So whenever you move something from one side of the inequality sign or equation sign to the other, you just switch the sign of the term. So it was a positive 3x on the left side. On the right, it's a negative 3x. Well, I'll just go up 2 spaces. That's my y-intercept there. The slope's negative 3 to 1. So down 3 over 1 to the right, down 3, 1 to the right. Or you could go up 3, 1 to the left. You can see on that same line. Well, from that point, we're going to go ahead and draw that line. And so this is going to be a solid line. And the solid line represents points that are solutions. And typically, it's just a border between where solutions are and where solutions are not. But since it has the line underneath, those are solutions. Now, the positive y is greater than. Greater means that you're going to shade towards the bigger numbers, because shading represents solutions. So all the y values are going to be bigger than they are on this line, or equal to it. So bigger means on this side of the line you would end up shading. And so that's what you're going to end up seeing, is it shaded on this side. Next one, same sort of thing. Subtract that 2x from both sides, take it away, and you got now y is less than or equal to negative 2x plus 3. So start with that y-intercept up 3 spaces, use the slope, down 2, right 1, down 2, right 1, down 2, right 1, and then go ahead and draw that line. Another solid line, because the line underneath represents those are solutions. Now we got to figure out the shading. Well, the shading this time is a y is less. Less means smaller. You want smaller y's. And so smaller y's are going to be on this side of the line. And so that's the region that we'd end up shading. So the shading just represents solutions. The y values need to be less, so the less is below that line. Same thing over here, just take that x away from both sides. You now have y is greater than negative x plus 1. And so all you're going to end up doing there is going up 1 space and then using the slope. Down 1 over 1 is what this is. If you don't see a number out in front of x, it's just a 1. In this case, it's negative. And here we have a dashed line. The dashed line represents the points on the line are not solutions, but the values of the solutions are either on one side or the other side of the line. And since it's a y is greater, the greater y values are up above the line, because that's the direction towards bigger y values, up. And that's the region that you'd end up shading. Next one, you got to subtract the 2x from both sides. You end up with a y is less than negative 2x plus 4. So up 4 spaces, 1, 2, 3, 4, and then use the slope. Down 2 over 1 to the right. Down 2, 1 to the right. And then you shade, or you draw the right type of line, I guess, is the first thing. So we got to do a dashed line again. It does not have that line underneath. No line underneath. That means it's a dashed line. And then from that point, we look at the shading. Positive y less. Less means smaller. Smaller is below. So that's the region that you'd end up shading there. So just a couple notes here. So remember, if it's a positive y is less or less than or equal to, we go below the line, and that's the region that you'd end up shading, shade below. If it's positive y is greater than or equal to, then you end up shading above. So that's something to remember. And then dashed line, we do not have the line underneath, so we have a dashed line. Dashed line means that you have one of these two types of inequality signs. And then we add a solid line. A solid line has the line underneath the inequality sign. Question number 20 is going to ask you to determine whether it points on the line. You're just going to take your x value and your y value and put it in for x and y in the equation. So 6 in for x, 18 in for y. So now we have 2/3, and we're going to multiply that by 6. And treat 6 as a fraction, like 6 over 1. And then equals 1/3 times by y. Well, treat that as like 18 over 1. And then minus 2. So do some work there. You got to cross cancel first. 3 goes into 6 2 times. Multiply across here, you get 4. And 4 equals, 3 goes into 18 6 times. So 6 minus 2 makes 4. So 4 equals 4. So when the numbers equal, then yes, that point is on the line. So it's the same thing here. Negative 5 is going in for y. 6 is going in for x. Remember, this is the opposite of x, so it becomes a negative 6 plus 6 times by negative 5, and this all equals 24. So we do some work there. Negative 6 plus negative 30, and see if that equals 24 or not. And when I add those numbers, I do have to add, I get negative 36, and those two numbers do not equal, so that would be a no. They're not. That point is not on the line. Next one, 9 in for x, negative 2 in for y. So 1/3 times by 9, treat that as like 9 over 1, minus 2 times by negative 2 equals 7. So you do some work there, and we see that that 3 goes into this 9 3 times. So 3 plus because the two negative signs there make a positive. And yes, those two numbers do agree, so yes, that point is on the line. 1 4/10 goes in for x, or x is way over here this time. 0 goes in for y there. So 0 times by any number just makes 0. So that'll cancel out. Equals 10 times by 1 4/10 minus 14. So this makes 0. And 0 equals, this makes 14. Just decimal moves over one space when you multiply by 10. 14 minus 14, yes, that is 0. So the two numbers agree, so that would be a yes as well. 21 through 23, those questions are asking us to write a linear equation using point slope. And so the question might have us just use point slope, or might have to have us solve all the way and find out what the slope-intercept form is. So I'll use the slope-intercept form, but I'm going to write down the point slope formula for you. Y minus y1 equals m times x minus x1. So basically we want to find out what the slope is. Well, that's already given to us, so all we have to use is the slope in for m and the point in for y1 and x1. So here's our x1 value, here's our y1 value. So I'm going to substitute. Y minus 2 equals the slope 1/5 times by x minus negative 5. So we go ahead and do some work. You just add the opposite where you need to. And we have now y minus 2 equals 1/5 x. And this is going to be a plus 1. Plus 1 because notice how the 5 goes into 5 one time. And so all you have to do from this point is just do an opposite operation. So here we're going to end up adding 2 to both sides. So I add 2 to the left, add it to the right. You got now y equals 1/5 x plus 3. And that would be our answer. Well, taking a look at the next one, here, same sort of thing. We're going to use that point slope formula. Y minus y1 equals m times x minus x1. So we just plug in that slope in for m, and the first numbers are x1 value, the next numbers are y1 value. So we have y minus 1 equals the slope, which is 4/5 times by x minus negative 15. So whenever you see that minus negative, quickly change that to plus positive and distribute. So we have now y minus 1 equals 4/5 x. And over here, 5 goes into the 15 3 times. You multiply 3 and 4, you get 12. So plus 12 there. And then all you have to do is move that 1 back to the other side. So you end up having to add it to both sides here. So add the 1, and we get our answer. Y equals 4/5 x plus 13. Well, the last two problems are going to ask us to find the slope first. So remember, the slope formula is y minus y1 over x minus x1. So it's the difference of the y values over the difference of the x values. But you don't need all these points. You just need 2 of them. So let's cross this one out. It doesn't matter which one we cross out. I'm just going to cross one of them out. And then you start with 1. So 0 and 3, those are the y components. So I'm going to do 0 minus 3. So since I start with the 0, I've got to start with the negative 1. Negative 1 minus 0. So I did negative 1 and 0, those two, and then these two. And so I do the work, I get negative 3 over negative 1, which just makes 3. So 3 is the slope. And so I'm going to use one of the points. I'll use that first point right here. And so I do y minus 0 equals 3 times by x minus negative 1. So I just substitute the point negative 1, 0 in for y1 and x1. Do some work there. Y minus 0 equals 3x plus 3. Plus 3 because plus positive. End up distributing, you get that answer. So nothing to, y minus 0 is just y, so y equals 3x plus 3. And that would be our answer. Last one here, again, just cross off one of the numbers. I'll just cross off the last one there and find the slope. The slope is going to be the difference of these two y values here. So 5 minus 3. Since I started with the 5, I got to start with the negative 2. Negative 2 minus 2, and I end up with a 2 over negative 4, which would end up reducing down to negative 1 over 2. So that's the slope I'm going to use. And then just pick one of the points. Let's pick this one right here. And so I'm going to do y minus 3 equals negative 1/2 times by x minus 2. And so I have to distribute. So I distribute this 1/2 over, negative 1/2 over that subtraction. Get y minus 3 equals negative 1/2 x, and then plus 1. Plus 1 because the two negatives make a positive. 1/2 of 2 is 1. So last step there, it's just a matter of adding that 3 to both sides. So add the 3 to the left, to the right, you get y equals negative 1/2 x plus 4. That would be our answer. So those are the problems that you'll see for 19 through 23.